Hi there, welcome back. This is going to be the second video in section 6.3 where we're talking about the sine and the cosine graphs. So if you'll go down to the fourth page here, we're going to be taking a look at some examples. Before I do this, notice that the sine and the cosine are going to be related to the unit circle. The domain is going to be consisting of the real numbers that correspond to my angle measures. The domain is either in degrees or most likely radians, but they're going to be the x values are going to be my angles that are on the unit circle. The range is going to be either, if we're talking about the sine graph, it's going to be the y values of my coordinates. And if we're talking about the cosine values, it's going to be the x values of my coordinates on the unit circle. So just realize that this all does go back to the unit circle. All right, so when we are looking to get an example done, to draw an example, there's a couple things that you'll want to know. First of all, if you want to divide your interval into 4 equal parts, I've been walking through this with you when we drew the parents, and I'll continue to model this for you. First of all, you want to go all the way to the ending value, and that helps me with the period. Then you want to find the halfway point, so you just take half, and then you take half again to get that first quarter point, and then at that point you can just simply count from there. And like I said, I will model that for you. All right. The amplitude of a graph is going to be how tall the graph is. How high does the graph go? And you notice here that the amplitude, its formula is going to be the absolute value of A. Now, before I jump into this heavy, notice that my A is going to be that number that's being multiplied out in front of my sine or my cosine. So in my first example, notice that my amplitude occurs at a value of 1/2, which just simply means that I want to take my sine graph up to 1/2 and down to -1/2. All right, so once again, let's practice getting my 4 intervals. So you go all the way to the end, and the period here is still 2 pi. Take half of that, which is pi. Take half of that, which is pi over 2. And then you just simply want to count. So you have 1/2, 2 halves, 3 halves, and 4 halves. My sine graph always begins at the origin. So I'm going to go ahead and put my sine graph here, my original point at the origin. And this guy is going to go up to 1/2 and down to -1/2. The parent went up and down to 1 and -1. This guy is only going to go up to 1/2. All right, so we understand here that the beginning, the middle, and the ending of my parent sine are going to be x-intercepts. The first quarter is going to be a maximum, and the other quarter point is going to be a minimum. Once I have those 5 values, I don't need to do any plugging and chugging. So we're going to just go ahead and connect the dots. And we have a graph that shows the amplitude of 1/2. Now, we can think of this graph as a vertical stretch or a vertical shrink, thinking about what we did back in previous math courses when we were translating or transforming the parent graph. So this is going up, in this particular one, it's going half as high as the parent does. In general, the graph of a function, going on to the next concept here, in general, the graph of a function that has not an A value now, but notice that I have a B value, and it's actually being multiplied by my angle. A lot of times we'll put this in parentheses, not always, but a lot of times that we will. B here is, we are going to be dealing with a positive B value. What we have is it's going to affect the period of my graph. We know that the parent period is going to be 2 pi. The period of my graph now is going to be affected. All right, so when that B value is positive, the graph is going to look a whole lot like the parent graph, But the formula for the new period is going to be 2 pi divided by b. And this is going to be for both the sine and the cosine parent graphs. All right, so let's take a look at how this affects my graph. Let's do an example. Notice that the amplitude of this example is going to be 1 because there is no a value out front. The period is going to be 2 pi divided by b. So that's going to be 2 pi divided by 1/3 multiplied by the reciprocal, and that'll be 2 pi times 3, which is going to be 6 pi. All right, so then how does this affect how I draw my graph? Well, first of all, go all the way to the end to draw the period. So the end, let's get 4 values here. I like to go out four equal values, and the end is going to be 6 pi. Because that's my period. That's how far I'm going to go before I repeat my graph. Take half of that, that will be 3 pi. Take half of that, that will be 3 pi over 2. And then I can just count. So I have 3 halves, 6 halves, 9 halves, and then the last one would be 12 halves. And of course, you see that 2 of those were reduced. Again, this is a sine graph, so my sine graph is going to have x-intercepts at the beginning, the middle, the ending. It's going to have a maximum at the first quarter and a minimum at the other quarter. We are just going up and down to 1. So then I can just connect my 5 values, and I have my new sine graph drawn. This is like a horizontal shrinking and stretching. So I'm stretching it or shrinking it from side to side. Are these two the exact same thing? The sine of 2x and 2 times the sine of x? Well, no, they're not. The first one has a horizontal shrink, and the other one has a vertical stretch. So no, they are not the same thing. All right, let's try example 3 here. So for example 3, again, you take a look. I have no a value, so my amplitude, once again, is going to be 1. The period is going to be 2 pi divided by 1/2. When you multiply by the reciprocal, that's going to be 4 pi. So once again, let's get 4 equal values. So I'm going to go every 4 tick marks here. My ending value is going to be the same as my period, so I'm going to go out 4 pi. Take half to get 2 pi, take half to get pi, and then I can just count 1 pi, 2 pi, 3 pi, 4 pi. Since I'm going up and down to 1, we'll go ahead and mark those. This is a cosine graph, so remember that the cosine has maximum at the beginning and the ending. It has a minimum in the middle, and it has x-intercepts at the 2 quarters. Once you have those 5 values, then you can easily connect the dots to get your cosine graph. All right, some guidelines for sketching. The first thing that you want to do to be able to graph is simply figure out what your period is. And you're going to use 2 pi over b and mark that distance. Then you want to divide your interval into 4 equal parts. We call them the 5 major values. And then these 5 major values are going to either be a max, a min, or an x-intercept. You want to connect the dots and join them having an amplitude of the absolute value of a, and then just simply draw. All right, so let's do example number 4, where we're going to be combining 2 things in one. So notice that my amplitude is going to be the absolute value of -3. Okay, so that's going to be an amplitude of 3. I did unhide that. That negative is going to reflect my graph over the x-axis. That's something that we would have done in a previous math class. Negative out front causes it to reflect over the x-axis. And then my period will be 2 pi divided by 2, which then reduces to pi. So once again, let's go ahead and let's mark out 4 equal sections there. The ending value is going to be pi. Take half, which is pi over 2. Take half again, which is pi over 4. And then I can just count 1/4, 2/4, 3/4, and 4/4. I'm going up and down to 3. This is a sine graph, and a sine graph is going to start at the origin. Notice though, well, I'll go ahead. The beginning, the middle, and the ending are all going to be x-intercepts. Normally, my sine graph would go up first to a maximum, but because I've reflected over the x-axis, I'm going to go down to a minimum first, and my other coordinate, my other quarter, will be my maximum. So we can connect the 5 values to have my sine graph. All right, I'm going to go ahead and pause this particular video, and we'll come back and do some more examples later on.